Hello and welcome. My name is Bosco Can and my student ID is 10062145. So me and my partner were able to implement all the effects in Lab 4, and first we have Bouquet horizontal, and then Bouquet A, which is tilting to the right, and Bouquet B tilting to the left, and we have Bouquet composite going all directions. So in order to generate these effects, we will need to implement two new fragment shaders and some changes in the default shaders. So first we need the bouquet fragment shader. So inside we need to have the version and then set up two materials to bind to, which is one is uniform sampler 2D depth, and then one for texture, and then a uniform float called filter angle, and then vertex data, and then we need to set up a constant called variable called number of samples to and then set it to 13. And so here we have a function called void calculate offsets, and then it takes in a float angle, an output vertex vec2 offsets, and it's an array, and it has the number of samples, which is declared up here, which is 13. 13. Yep. And so within it, we first initialize some variables. One is float aspect ratio, and we set it to 1, and then float radius we set it to 0.5, and then a vec2 variable called pt, and which it's equals to vec2 radius multiplied by cos of that angle, and then radius multiplied by the sine of that angle, and then with the PT in x direction, we divide it by the aspect ratio, and then we have a for loop that I is equals to 0, and then we'll compare it up to the number of samples, which is 13, and then I++, and then we set up a variable called t, and it's float. And so when I has the divided by number of samples minus 1, and then the offset at I will equals to mix negative pt, and then a pt and a t. And then next we have a vec4 function called Bouquet, and it takes in a vec2 offsets array, has a number of samples of 13, and then we initialize some variables. First is float bleeding bias, and we set it equals to 0.02, and then a float bleeding multiply equals to 30, and then vec4 center pixels equals to texture, and then it takes in the u underscore text, and then the texture coordinates in x and y, a float center depth, same thing, but different, takes in different variables, which is taking in the depth and the depth coordinate in x and y, and then a dot x at the end. And then we set the color to vec4, which is I think it's black, and then a float total weight equals 0. And in this for loop, obviously we're gonna go count it up to the number of samples, and so we initialize an offset to equals to that offset array at t, and the sample coordinates equals to texture coordinates in x and y plus offset multiplied by center pixels dot a, which is alpha, and then sample pixels, vec4 sample pixels equals the texture u underscore text, and then sample coordinates, and then a float sample depth equals the texture, and then u underscore depth sample coordinates, and then dot x, and then float weight equals the sample depth. If it's smaller than center depth, then either it will be sample pixel dot a alpha multiply by bleeding multi, or it's equals to 1. So weight, it will be equals to center pixel dot a larger than sample pixel dot a plus bleeding bias. If that's the case, then either weight will equals to the weight in here or equals to 1, and then we do a clamp with the weight and then a 0 and 1. On color, we'll add with sample pixel multiplied by the weight, and the total weight will be added from the weight initialized here, and then we'll return the color divided by total weight. And then the main, we have float angle, and then it's equals to filter angle, and then we calculate the offset, vec2 offset, number of samples, calculates offset, and takes in the angle and the offsets. And then finally we have output color, which is equals to calling this bouquet function and takes in the offsets, which is this array. And then the second one is bouquet composite fragment shader, and it's fairly easy. Two things, bouquet A, bouquet B, to bind the materials, and then same thing. And then we have a vec4 FBOA equals texture of the bouquet A and the texture coordinates in x and y, and then same thing but another variable called FBOB, and then output, like the fragment color, will be equals to the minimum, like calling this minimum function, and then we'll take in FBOA and FBOB, and then the fragment color in alpha will be at the highest intensity, 1. And so in the default fragment shader, type in version and then set up the uniform vectors like position, color, and the cam, which is the camera, and then set up other floats variable, A for aperture, F for focal length, S1 for focal distance, and max COC for max COC diameter. And then so we have two functions. One is float, and it's called calculate circle of confusion. So we first initialize a float S2 equals the ABS, and then takes in depth I, which is the I position from the objects, and a float C equals the aperture multiplied by ABS, S2 minus S1 divided by S2 multiplied by F, the focal length, divided by S1 minus the focal length. And then other floats variables, sensor height is equals to 0.024% of sensor equals to C divided by sensor height. Blur factor equals to the clamp, using the clamp function, takes in the percent of sensors and then have 0 and then the max COC diameter, and then obviously it has to return the blur factor at the end. And then another function is vec3, and it's called calculate pixel color. And then we first initialize two vec3 variables, L and N. So L will be equal to the normalized of light position in XYZ directions minus position of the post I, which is the position of the camera, and then an N will be equals to normalize of that normal, that from the vertex data. And then another float variable called diffuse is equals to max using the function max, takes in a 0 and dot N and L, and then it returns a vec3 0.5, 0.5, 0.5 multiplied by diffuse, and the diffuse multiplied by 0.8 and plus the color in RGB, and then output color RGB will equals to calling the calculate pixel color function, and then in the alpha channel it will call the calculate circle of confusion.
Hello, I am Jarvis Ortega, and as Bosco explained, he in the part before this, he explained what you do in the fragment shaders with Bouquet and Bouquet composite on the textures. He explained the code in the shaders, and I will then explain the code in the main file, in the main CPP. So, Bouquet, what we use for Bouquet is frame buffer. So, what you do is you make some game modes. You make one for the horizontal, one for B, one for A, B diagonal, and then the composite, which is all those combined. And then because we are using frame buffers for this, you have to create frame buffers like as you see right here, and then initialize it to the window width and window height, because it's going to do the whole screen. It's not going to be like the bloom, which you take like half of the screen to create this bloom effect. We're going to take the whole screen. So we'll go down to where we actually put the code in. So you put the shaders in. After that, you put your cases for here's the bulk and horizontal. So you choose the bulk and pass, and you pick the FBO scene and the horizontal, and then you set the angle at which they will, which the blur will happen at, and then you just draw that on the screen. So as you see right here, in horizontal, you can see how the blur is going from one end. I'm going from that left to right. There's no angle, it is going 0 degrees. And then that's the same for broken A, but this time we're going at a diagonal. So we set it to an angle of 120 right there. You see it over there, 120. Here's the broken A. You can see how it goes from this way to that way. It goes at an angle of 120. And that's the same for broken B right here. We just set it to the opposite way, so minus 120. I'll show you that right here. What's the 120? It was in another direction. Now, to combine it, we have to put all the bokeh paths together. We just blur all the images horizontally, and then diagonally at the 120 and negative 120 with bokeh A and bokeh B. We unbind the frame buffers, clear it, and then we set the material to the bokeh composite material. And then we bind those textures that we made in the shaders, and we bind it to bokeh A and B, and then send it out and draw it so that they all combine together. And then at the end you get this cool, you get the diamond look that you usually get from light like that. So right there, there's a combination of the horizontal, diagonal A, and diagonal B to create the look of Vulcan composite, as you can see as I'll go through. Thank you.